All right. Let's make sure volume's up. I believe we are in business. Let people log on. Go ahead and reshare the link. Do do do. All right. Wait, maybe 1 or 2 more minutes. All right, I'll just get started here. So, thanks for watching, but let's dive into this. So, in this live stream, I want to cover implementing output guardrails for an AI function using an LLM using the j1-micro model from haizelabs. So, first, I just want to talk a little bit about why we would want to do something like this. The first thing is that output guardrails can be an effective way to provide some kind of nuanced validation. So often people are familiar with some kind of structured output where you more or less just give a schema that you want a response to adhere to. And a lot of the providers implement in different ways, but most of the time it comes down to outputting some kind of JSON structure, and then you can validate it. But the types of things you can validate with, you know, traditional code is somewhat limited, or at least not complete. So, for instance, if I want to have, um, if I wanted to validate the tone of a particular message that the bot is outputting to make sure it has a professional tone, I might want to make sure that uh, that happens because I don't want the AI to output something that's being rude to a customer. But at the same time, it's really hard to write a function that validates that. And so using some kind of AI based solution is actually a good call there. So that's why we want to have output guardrails. Now, output guardrails are generally implemented in essentially the hot path. So it's something that's applied right after the response of the AI function. And That means we want it to run fast, which kind of means we need a smaller model. And haizelabs has done some incredible work to show that you can create pretty good reward models with small models. And so, one of the things I'll just kind of call out here is you might hear me use the words like judge, reward, or verify. I kind of use these interchangeably. I don't think some people use those words in a way that has like a little bit of nuance between them. So, for instance, a verifier might just be something that tells you whether it's right or wrong, true or false, and a reward might give you a real value number for how valuable or how much reward you get. But you know, suffice to say, like all of these are really just ways of how do we kind of score the response in a way. Um, all of this code I will be putting up in a GitHub repo that I will link out in the YouTube show notes afterwards. But yeah, so what we'll be doing, like more concretely, first thing we're going to do is set up haizelabs to be served via Olama. So the way that the haizelabs models are uploaded to Hugging Face right now, it works if you want to run it through VLLM, but VLLM is not compatible on a MacBook, which is what I'm using here. Olama is just typically what I run local models through. It tends to be simple. That being said, the j1-micro model is a LoRa fine tune of the Quinn 3 1.7B model. And basically, what that means is we're going to have to go through creating a gguf file, which is basically what the Olama software can work with. But we're going to create a gguf file, not of the whole model, but just of the adapter. Because all j1-micro is it's this LoRa adapter that's on top of the base model. So the way LoRa effectively works, if you're not familiar, it can be pretty expensive to just fine tune the entire model. And so what LoRa does is it puts these low rank adapters, meaning that we can optimize a smaller set of parameters and still get pretty good performance. But what it means is there's kind of like a merging step that needs to happen at the end. And you could merge these together and then save a new model that's where you have a gguf that's the complete model. It is simpler or more straightforward, I think, to just create the gguf of the adapter. And then Olama has a way for us to specify the base model and then point to the gguf of the adapter and then create a model from that. So we're going to go ahead and do that. And then after that, we can jump into some code and then have a create essentially an output guardrail that has a judge prompt. And we want to make sure we use the same sort of template that j1-micro was trained on because it was fine tuned on a specific template. And so we'll go ahead and make sure we copy that in. And then we'll go ahead and add that as a validator to an LLM function. So that's what we'll be doing. So let's get started. So one thing I need to do, I meant to do this before off stream, but I can just do it now pretty easily. I need to set up my keys. So I'm basically I already have an OpenAI API key here. So I'm just going to write this into my im file real quick. So now we have that in my im file. And then I'll basically just make a main.py file that we'll be working in. And so we will end up doing some stuff here later. But to start, we want to go ahead and walk through those steps I mentioned of creating the model. So if you install Olama, which you can install through Brew, or there are other methods. If you just Google Olama install, you can pretty easily find the install instructions. But if I run list, I get a list of all the models that I have installed. You'll see that I have this, j1-micro thing, and that's because I already walked through this process. But just so you can see it, I'm going to walk through it with you again. So really, the first thing we need to do is download the weights of the haizelabs model, and then also the base model that it'll be using. And so the way you can download that is by using the Hugging Face CLI. The way I like to install CLI tools like that, ooh, the way I like to install CLI tools like that is really to use UV. And so you can use UV tool install, and we can say Hugging Face Hub CLI. And so now I have the Hugging Face CLI, but uh, now that allows me to use UVX to run Hugging Face CLI, and it's in like an isolated Python environment. So pretty much anytime you're using like Python-based tools that you could install via pip, I really like using UV. Makes it pretty straightforward. And so the models that I want to download. So the first one is going to be haizelabs j1-micro 1.7b. And so you can just use the download subcommand of the Hugging Face CLI. Ooh, why didn't that work? Okay, I might just have to, instead of UVX, UV tool run. Let me try that real quick. That's interesting. Let's see. UV tool. No solution found. Hugging Face CLI was not found in your package repository, and you require Hugging Face CLI. We can conclude the requirements are unsatisfiable. That is very strange. Am I like spelling something wrong? Let's see. UVX. I'm gonna need to look this up. I don't know why this isn't working. Hugging Face UVX.